By the 1970s, nearly 2 decades before the World Wide Web, development and use of computerized information retrieval systems continued to expand. The following excerpt from 1974 shows 4 such computerized information retrieval systems: DIALOG, AQUARIUS, SPIRES, and LEADER. The Lockheed DIALOG system was developed at Palo Alto Research Laboratory in 1966 and available commercially in 1972. AQUARIUS, used by the U.S. Legislative Information Center, was part of the SPIRES storage and information retrieval system, developed by IBM. SPIRES was the Stanford Public Information Retrieval System, developed in the late 1960s at Stanford University. LEADER stood for Lehigh Automatic Device for Efficient Retrieval, conceived by Professor Donald Hillman in the 1960s, at Lehigh University, Pennsylvania. LEADER was operational by 1965, and ran on an IBM data acquisition and control system. The excerpt also shows a computerized ticket office in California, including a Control Data Corporation TICKETRON terminal. TICKETRON was an early forerunner of Ticketmaster. You will also see an experimental computerized information retrieval system at a bookstore in Berkeley.
One example is the Dialog system at the Office of Education, San Mateo County, California, where specialists answer requests for information from school teachers. Using the retrieval system, they search a database containing over 100,000 documents. Rapidly, the file is narrowed down to a small, pertinent subset. Five to 10 of the most relevant documents are chosen, and microfiche copies are sent to the teachers. Descriptions of more than 1.5 million satellite photographs of the Earth make up one of the databases of the NASA system. Each photograph is recorded as a citation, including location, date, cloud cover, type of terrain, and other features. Geologists, ecologists, agronomists, and other physical scientists can then easily determine which photographs pertain to their research. Once identified, reproductions are sent to them for their use. Another system in use at the House of Representatives handles more than 24,000 bills considered by Congress annually.
Yes, I understand the problem you're having. Let me check and find out where the bill is. I've forgotten just what happened on that. Just a second. Hold on, will you please?
Bill Status Office, Patty Costa, may I help you?
Hi, yes, I need the information on the railroad retirement bill. I thought we'd passed that last spring. Can you check it for me, please?
One moment, please.
Yes?
May I ask your office, please?
Yes, I'm Congressman Pete McCloskey, California.
I believe the bill you would be interested in is H.R. 7200. That bill was introduced by Congressman Staggers and reported out of the Interstate and Foreign Commerce Committee. On May 22nd, it passed the House by a vote of 387 to 5. On June 19th, it passed the Senate by a voice vote, and after completing conference, was signed by the President on July 10. It is now public law number 93-69.
Fine. Thank you very much.
You're welcome.
Hello? Hi. Let me tell you what happened.
In April 1973, Congressman Wayne Hayes announced the introduction of this new information service. Within 6 months, the Bill Status Office was handling more than 800 calls a day from congressmen, government employees, and the public. It might seem that information travels only from the database to the user. However, the SPIRES system at Stanford University allows users to put information into their own databases. These can then be made available to the entire community of users. An example is a constantly growing restaurant file, created and maintained by student gourmets. This file contains the name, location, price range, type of food, and criticisms of each restaurant. After a careful search of the database, a prospective diner can make an informed choice based on the experience of others. Here, the leader system at Lehigh University is being used to demonstrate a simple search. The request is entered in language comfortable for the searcher. The system takes the major words in the request and immediately displays phrases containing those words. The searcher studies the phrases to decide which are most suitable. Abstracts of documents can then be displayed to see if they match the searcher's needs. Reading these may suggest other phrases, or the searcher may ask to have a list of related phrases shown. Again, the searcher goes through the procedure of looking at phrases, then examining documents, repeating this process until satisfied. With the leader system and most others, a searcher typically spends 15 to 30 minutes at the terminal in order to retrieve about 50 documents. Another approach to searching encourages the user to break the request up into its basic concepts by grouping synonyms into sets. Then, by intersecting them, it's easy to see how many documents can be retrieved. If there are too many, it's possible to get only the most recent by applying a qualification like date after 1968. Concepts can be narrowed, broadened, or recombined until the searcher is satisfied. The system interface provides the means of communication between a user and the information stored in a database. The users of these systems, scientists, lawyers, doctors, businessmen, and students, must use terminals for their part in the communication. Doctor, we must have a terminal. Now let's consider the databases, which fall into three categories. Document retrieval is concerned with retrieving sets of individual records. Management information processing is concerned with retrieving and combining records into reports and graphs. Question answering is concerned with providing specific answers to a wide variety of questions. Presently, the functional needs of document retrieval are largely known. Management information processing is less well understood, and question answering remains in the research stage. In the future, as their functions increasingly overlap, the differences between these three will almost disappear, and generalized systems will emerge. Various media are used for storing the information in a database. While tapes are used for batch retrieval, interactive retrieval relies upon disks, drums, and data cells. For all types of users and databases, The important characteristic of interactive retrieval is the quick interchange of information, with the system interface providing the necessary means of communication. These systems have been designed to operate on many different computers. The performance of this hardware ought to be unobtrusive, freeing the user to concentrate on the task of retrieval. Today, searching costs range from $25 to $100 an hour. Networking would allow many people to share this expense. TYMNET is an example which connects people to computers by phone. Another is the ARPA network, which ties individual computers together. In the future, additional networks will reach many more communities.
Yes, it is. Most recent first, 1973 article.
As access to systems continues to increase, the professional intermediary will remain important. Two heads are better than one for solving problems.
Hi, I'd like a reservation for a campground at Big Sur. When did you want to go?
You're going through the training program. You're pretty much, in the
For 2 nights?
in the line.
3 nights.
Except you can only go so far with just
It is also likely that central information locations will develop where a person can pay a small fee to have a professional help with the retrieving.
We still have campsites available for those nights.
Okay, well, can we have 2 cars at one spot?
Good afternoon, TWA reservations, Miss Bean. Let me see if it's coming in on time today.
As use of information systems becomes popular, there may not be enough intermediaries to meet the demand. Eventually, people will become accustomed to doing their own searching. An example of this is an experimental terminal in the corner of a record store in Berkeley, California. It is operated by a cooperative and presently is free to the public. Eventually, they hope to build a user community large enough to be self-supporting while charging only nominal fees.
You know, if you're not interested in that one, you could also put in an ad that you're looking for one. You want to do that?
Well, this time I was actually playing around with it, but I think that I might use it in the future for when I might be looking for an apartment or something like that.
Do you want to look for something, or do you want to advertise?
I want to find gigs or auditions in a band, a certain type of band.
Oh, are you part of the band that's looking for jobs?
I'm alone, looking for an established
You're looking for a band. I
Right.
see. Okay. In that case, what do you play?
Guitar, jazz. You can get pretty much down to what you want. You know, if there's anything that you want that's been fed into the computer, you know, you're likely to find it very easily. The old system was to have a lot of pieces of paper on the, well, there's still a few, but there were many more, and it was very chaotic and difficult to find exactly what you're looking at. There's no kind of order to it. You have to just look around at random, and, you know, it's pretty good. I mean, there should be computers like this in a lot of places, you know, so any musician in town is, I mean, I don't know how many people know about this.
Because of the number of situations where information is needed to solve problems, people are going to continue pooling their knowledge. Interactive information retrieval systems will increasingly reduce the time and effort needed to gain access to this information.